Hello everyone, welcome back to the series. So, as you know, we are in a series where we take an interview experience from lead code and try to solve all the questions of that and all the possible follow-ups of those questions. So, today's uh, today we took this particular on-site Amazon on-site interview experience. We already solved this first problem and all its possible follow-ups apart from this given one in another video. If you are interested, you can go through that. This we will now consider solving. Like I will not be solving the second question because this is very straightforward. You can go through the question yourself and try to think of the approach. If you're not able to do so and you want me to create a video about this, you can let me know. I will upload one. So in this video, let's try to solve this particular question wherein we have to solve this specific lead code 207 question. So let's start. So the question states that we are given to some number of courses and each course is labeled from 0 to number of course minus 1. Now we are also given this prerequisites array wherein we are saying that to take course AI, we should have already completed the course BI. Okay, so that's what the prerequisite array denotes. So we have given lot of such dependencies. Uh, in particular, there are total 5,000 dependencies like this, and we have to figure out whether it is possible to do or undertake all the courses. If yes, we return true, otherwise we return false. So let's try to understand this with an example. So here what we have done is we have just collapsed this prerequisites array. So basically this prerequisites array says that to take AI you need to take BI. So we have just collapsed all the prerequisites for one, similarly for two, and so on. So basically this denotes that to take one you need to undertake two, three, and four course as well. So that's the problem. Now let's try to understand the let's try to just understand whether it is indeed possible to take all the courses in this scenario or not. So first of all, we can see that there is no dependencies on the fifth course, so we can take this fifth course independently. Let's say we completed this fifth course. Now as we have completed this fifth course, we let's cut out this. Now we can see we can undertake these two courses. So we previously we these two are dependent on five, but because we have already completed this fifth course, we can take third and fourth course as well. So let's cut out all the dependencies. Now you can see we can take the second course. It was dependent on fifth and the fourth course, and we have already taken them. So let's cut out this as well. Now you can see we can undertake the first course as well, which was dependent on 2, 3, and 4. And as we have already taken them, we can take this one as well. So indeed, we are able to complete all the five courses given this scenario. Now, there can be another scenario as well. So like this. So let's say this is the uh, dependencies array that we just saw. So let's try to evaluate whether we can complete all the courses or not in this particular scenario. We can undertake the fifth course easily because it doesn't have any dependencies. Now this will unblock us to take the course 3. So let's take the course 3 as well. Now you can see we can't take any of the remaining courses, like we can't take 1, 2, or 4. So because each of them is now depending on someone, which in turn is depending on someone. So that's where we can't take any of these courses, and hence the answer for this particular scenario will be no. Like we can't take all the courses. So now how to solve this? So basically we can just simulate whatever we have just done, right? Like we can just currently what we have done is we try to take courses which are which doesn't have any dependencies, and then after taking the course we cut down that dependencies from all other courses. So basically after taking fifth we have cut down the dependencies of fifth from all the courses. So that's what we will do. So let's say uh, now how to do it efficiently. Let's say we are doing this in a brute force manner. So basically for every course here, let's say we completed the fifth course. Now we go through each of these courses, and then whichever has five in them we will just remove it. So this will require us to, like, every time we complete a course it will require us to go over the rest of the courses. So in total if there are n courses, every time we complete a course it will require us to go over remaining n minus 1 course, and hence the complexity for this solution would be of order n square, right? So that will not fit in the time complexity because number of courses is pretty huge. Now having said that, we have to just optimize this particular operation. That the operation is, we have to somehow figure out wisely that which all courses actually depends on 5. So with this let's create a reverse map. So basically the reverse map says if we do fifth course, which all course will be freed up. So if we do fifth course, which all course will be freed up. So in our case it is like if we do fifth course, third course has the dependencies on fifth. Similarly second course has the dependencies on fifth. uh, that's it. So now if we take fourth course, like let's say if we completed the fourth course, then second has the dependencies on fourth, first has a dependency in fourth. So first and the fourth, third, second course can, like, one of the dependencies of first and second course can be freed up. Similarly if we complete the third course, uh, like one has a dependency of on three, so one of the dependencies of first course will be freed up. Similarly if we complete the second course, uh, one of the dependencies of the first course will be freed up. Similarly if we complete the first course, uh, one of the dependencies of fourth will be freed up. So that's what we built. Now once we have this mapping with us, so then let's say we complete the fifth course. Let's say we have this mapping, and now let's say we take a queue with all these completed courses. So let's say uh, initially we can complete five, so we will put five in the queue. Now we will try completing one of, like, this is the array which will contain all the courses that can be completed. So currently only five can be completed, so that's why the five is only there in the array. Now once we will now first complete the course 5. So once we complete course 5 we can see one of the dependencies of 3 and 2 will be freed up. So let's also maintain a dependencies array, like 1 2 3 4 5. So basically this dependencies array will suggest how many dependencies are there for each of these courses. So for the one there are three dependencies, for two there are two dependencies, for three there is one dependency, for four there is one dependency, for five there is zero dependencies. So whichever has zero dependencies we will put them in the queue. So currently five has zero dependencies, so we put five in the queue. Now we will complete the five. After completed five we can see third and second will have one dependencies reduced, so this will be zero, and similarly this will be 1. Basically we have completed one of the dependencies of these two courses. So now as 3 is 0 we will remove 3 from the array and put it here. Now again we will pick one of them from this to complete. Let's complete the third course. So when we complete third course, one of the dependencies of 1 will be reduced, so this will be reduced to 2. Now currently there is no zero, like there is no course which have zero dependency, so there is nothing we can add here. So basically we have completed all the courses that we could have completed. So that's where now we can see we are able to complete two courses, but there were total five courses. So that's why the answer is no. So let's just try to understand the same with the positive scenario to be a little bit more clear. So So we will do the same thing. First, let's try to build the dependencies array, like how many dependencies for each course are there. So for one, there is three dependency. For two, there are two dependencies. For three, there is one dependency. For four, there is one dependency. And for five, there is no dependency. Now we will maintain the array which will contain the possible course that can be completed. And as discussed, we will again maintain a reverse map, basically to facilitate the completion once we complete a course. So basically, we have to remove we have to remove five from all the courses which are depending on five. So that's why we are creating this reverse map. So five, on completing five, one of the dependencies of 3, 4, and 2 will be removed. So one of the dependencies of 2, 3, and 4 will be removed by completing 5. Similarly, by completing 4, one of the dependencies of 1 and 2 will be removed. By completing 3, one of the dependencies of 1 will be removed. By completing 2, uh, one of the dependencies of 1 will be removed. And by completing 1, none of them are depending on 1, so it will not release anything. So now initially 5 is there with 0 dependency, so we'll add 5 to this. Now we will process 5. Once we process 5, we can see 2, 3, and 4, like one of the dependencies of second, third, and fourth course are already complete. It's already completed, so we will remove, basically we will replace this with 1. Similarly, we will replace this with 0, and similarly we will replace this with 0. Now once we have done this, these two are 0, so let's add this 3 and 4 to our queue. Basically we can now complete this 3 and 4. So now let's process 3. Once we process 3, basically one of the dependencies of 1 is freed up. So let's apply that here. One of the dependencies of 1 is freed up, so number of dependencies that 1 now have is 2. So after that, we will process 5, we will process 4, and once we process 4, one of the dependencies of 1 and 2 will be freed up. So basically this will become 0 and this will become 1. So this will become 1. Now we have a new 0 here, so let's add that to this list. Now we will process again 2. After processing 2, one of the dependencies of 1 will be freed up, so this will now become 0. Again 1 has 0, so let's add it to our queue, and we will process 1. And once we process 1, uh, like there's nothing that is depending on 1, so we don't change anything here. Now we can see we have completed 5 courses, and in total there are 5 courses, so that's count matches, so that's why the answer is true. So let's just quickly go through the code of this. uh, as discussed, we maintain a reverse map, basically dependence of every course. So A depends on B. So what we are saying is, if we complete B, A can be unblocked. One of the dependencies of A can be unblocked. So that's why we have this dependence array. And we have total dependencies, which is nothing but this particular array, which contain the total dependencies for each course. So A is dependent on B, so that's why number of dependencies of A we increased. Now we can take a queue which has like all the courses that can be completed. Now initially, whichever course has 0 dependencies, we will just that can be completed, so we will just add it to this queue. Now we will iterate over each of the elements of the queue one by one and complete them. So we will just pop it and complete that particular course. After completing this course, all the dependents will be unblocked. So basically, we are then iterating over all the dependents of this taken course. and just decrementing their dependencies. And if their total dependencies is now zero, basically they are now free to be taken up, we will just add them to our queue to complete it afterwards. When this loop is completed, we have already taken all the courses that we could complete. So if completed is not equal to number of courses, we will return false. Otherwise, we will return true. So that's the simple code for this. Now there is one more possible solution for this problem, which is basically using graph. So whenever like there is a clear cut intuition of a graph here, because there these dependencies are nothing but kind of edges. So we can model this as a graph, something like this. So basically, one is depending on two, one is depending on three, one is depending on four. Similarly, then two is depending on five, two is depending on four, three is depending on five to be completed, four is depending on five to be completed. So this is the graph. Now to answer this, whether we can complete all the courses or not, so let's think about when we can't complete a course. So let's say we have a course X. That course has some dependencies on, let's say, X1. That X1 has some dependencies on X2, and that X2 has some dependencies on X3. Now, so like, and so on and so forth. Now, when is the case that we can't complete this course X? This will be the case only when some of these dependencies are cyclic. Basically, to complete three, we have to complete two, and to complete two, we have to complete three. So this is kind of dependence cycle that we have formed. So we can't take two until we have completed three, and this is saying that we can't take three until we have completed two. So basically, we will not be able to complete any of these two, and because x is depending on x2 to be completed, x we will not be able to complete x as well. So if there is any cycle in this graph, we can say that we will not be able to complete all the courses, because if there is at least one cycle, there will be some courses which are involved in the cycle which can't be completed in any manner, because they are depending on each other. So our problem after building this graph then reduced to finding whether there is a cycle in this graph or not. So finding cycle in an unrated graph is very easy, because you can just maintain a visited array and just see if the node that you are visiting is already visited or not. If it is, that means you found a cycle. So basically, let's take an example. Let's say you have a rated graph, something like this. Uh, this is a like kind of directed graph, no arrows or something like that. Sorry, unrated graph. So if you have unrated graph, something like this, then you can just maintain a visited array, and if you ever visit a node which is already visited, then you can say there is a cycle, right? But in unrated graph, that's not the case. Like you can't just maintain a visited array and then say that whether the graph has cycle or not, because uh, of because there can be cases like this. So basically, you already visited five through this path. Then when you go down this path, so let's change the color. So when you go down this path, you will again visit five, but there is no cycle, right? Because you can see there is no cycle. Like this doesn't form a cycle. So that's the challenge with undated graph. So, basically, the idea is to like to take the visited array along the path. So basically, uh, if let's say you are traversing this path, okay, and somewhere down the line there is an edge which is pointing to some of the node which which you have just traversed, then there is for sure a cycle, right? So that's the idea. It's a pretty standard technique to determine the cycle in a directed graph. You can go through any of the videos in YouTube or this Geeks for Geeks article as well to understand the concept. I will link these in the description below. So hope you find this useful. If you have any doubts regarding the problem, please post them in the comments below. I will be answering most of them. So if you find the content useful, please like and subscribe to the channel. I will be posting this kind of videos more often now. So make sure to subscribe to get notified. Until next time, bye bye.